Okay, so the second half of what we're going to be doing in class tomorrow is 12.3, where we actually learn and use logs. So a logarithm is a function that we use when there's no way to get the bases the same. So that would be like if you had 2 to the third equals 3 to the x. There's no way I can change a 2 to become a base 3 or vice versa. And so that's where logs come in to help us. They allow us to rewrite it without the base as a major component. So here's our basic definition of a log. Log is the function. B, that's the base of your exponent. X is your exponent, and A is what it equals. So here you have b to the power of something, of x, equals a. This would be what it would look like in log form. So b is your base, x is your exponent, a is what it equals. And it has this circular pattern, so when you're trying to rewrite, this is one of the things you can do, is follow this circular pattern. It works the other going the other way as well, going from exponential to log form. You have log base b of a equals x. So it kind of follows a similar circular pattern when you're going through and rewriting. And we're going to be looking at today evaluating, which does involve some rewriting from log into exponential, and then we'll work the other way, exponential to log, I believe in another day or so. So when it comes to evaluating, so we're asked to find log base 2 of 32. Well, I know that this has to equal something, so I'm going to put equals x. It has to equal something. Then I'm going to rewrite it in exponential form. So I have my base of 2 to the power of x equals 32. So now it turns into one of the problems we actually just did. I think it was the first one from the 2-2 notes. So we rewrite as the same base, so 2 to the x, 32 is 2 to the 5th, so x would equal 5. And you might recall last year where you got to use your calculator. You'll still get to, but the problem is, if you don't recall, is that your calculator only works in base 10 and base e, which is a natural number. And so right now, if we're working in base 2, our calculator fails us. Now some of the more advanced calculators can do it, but I'm thinking of just your basic scientific. I'm not thinking of anything higher. So if you do have something higher, yes, your calculator might be able to do a base other than 10 and e, but I'd have to show you how to do that. Or you can figure it out. Okay, so then let's look at number 2. We're going to start it the same way. We know that this log base 29 of 1 has to equal something. And then I'm going to write it in exponential. So I have my base to the power of x, so 29 to the power of x equals 1. So this is also like similar to one we just did. If we're trying to get them to be the same base, and I have a 1 here, the only way I can get 1 is if I had 29 to the 0 power. So I'm going to rewrite this as 29 to the 0 power, because that's the only way we can get a 1. So that means x would have to equal 0. Okay, and our last one for evaluating here starts off the same way. We know it has to equal something, so we're going to say it equals x. And then we're going to write it in exponential form. So I have my base of 10 to the x power equals, now I'm going to write this as a fraction because that'll help me when it comes to solving for x. So this is 1 over 10, 100, 1,000, 10,000. So how can we rewrite 10,000 as a power of 10? We can bring it to the top and make it negative, specifically 10 to the negative 4. So that would mean x would equal negative 4. And yes, technically that one you could have done in your calculator because it is a base 10. Okay, the other part with logs that we're going to do today, because there's a lot more to logs than just this, these are just your basic converting and evaluating, is we have these log laws that help us expand logs that might be a little more complicated. It also helps us condense. And so what we're going to look at right now is we're going to look at the condensing with the laws. In class, we'll look at the expanding with the laws. So our log laws, the first one, there's only 3, says if you have log of 2 or more things being multiplied, then you can write them as separate individual logs by adding them together. So I can take log base b of m, of the first thing being multiplied, and add it to log base b of the second thing being multiplied. And if we had more than 2, we could just keep going as long as we're adding each individual log that we're separating. For division, so if you have a fraction in your log, you can separate it by doing log base b of your numerator minus log base b of your denominator. So very similar to the multiplying, except that we're going to subtract the logs and we get an equivalent statement. And then the last thing is, how can we rewrite it if we have a power inside of our log? So we have an exponent inside of that a term of our log. So how can we rewrite it? By bringing that exponent out front as a coefficient, we now have a log of just a single term. And the reason we like to have logs of just single terms is they tend to make things a little bit easier to combine if they're separated. Also, let's say we have an x in there, like a 2x, and I need to solve for it. Sometimes it's easier to separate the 2 from the x, makes it easier to solve for x. So using these log laws just helps us simplify and rewrite expressions to help us eventually solve more of these. Okay, so we have one more example where we're going to use these laws to condense all of this into just one log. Right now I have 1, 2, 3 logs. I want just 1 in my final answer. So we're going to just take it step by step. So the first thing I notice is that all 3 of my terms have a coefficient in front. So what do I do with the coefficient in front? Well, if I have a coefficient in front, it comes inside as the exponent. So I can rewrite log, whoops, I hope I put the O in there. I can write log base 5 of 49 to the 1/2 power. Minus, and same thing with the 1/3, I can bring it in as the exponent of 8. So I have 8 to the 1/3 power. And same thing with the 13, I can bring it in as 1 to the 13th power. So that was just using our third log law to bring all of those coefficients in as exponents. Now before I go further, I am going to do a little bit of simplifying, because do I know what 49 to the 1/2 is? Remember, the 1/2 is like a square root. So 49 to the 1/2 is 7. So I'm going to write log base 5 of 7. 1/3 is a cubed root, so the cubed root of 8 is 2. And 1 to the 13th power is just 1. Okay, so now I've got all my coefficients taken care of. So I've used my law 3. So now I notice that I have addition and subtraction. So I notice that the subtraction is here. So that means 7 is my numerator, 2 is my denominator. So I can condense this to be log base 5 of 7 divided by 2. And then I still have this log base 5 of 1. And then what do I know about the addition? I'm going to condense it using my first law. The addition tells me I'm going to multiply 7/2 times 1. So when I simplify that, my final answer would be log base 5 of 7/2. And there's your single log from that expanded one. Condensing is something that we're going to do a little bit more often, maybe than last year, because when we go to solve logs, it's going to be important that we try to get 1 on either side, a lot like how we did with our exponents. So a lot like how we did up here with evaluating, how we had to get the same base, 1 base on either side. We're going to have some things where we want to get a log, the same log on each side. So that way we can solve it easier. So in class we're going to do some expanding as well to get some practice on that. And then you'll have a worksheet where we do just some more practice on both evaluating, expanding, and condensing.